All right. Good morning, everybody, or good afternoon, depending on where you are in the world. I'm Liz Wilson. I am the marketing director here at Ground Control. And today we're going to be covering off NTN NB-IoT Uncovered, what it is, what it isn't, and where it wins. The people speaking will be Oliver Potter, who's our CEO here at Ground Control, and Simon Hawkins, who's the Commercial and Innovation VP at Viasat. We've got a lot to cover, so I'm not going to give them the opportunity to introduce themselves. We're just going to crack straight on. Just a brief bit of admin as much as anything. There is a Q&A panel. Please use it. We have a very large number of people registered for this webinar, so I think it quite likely we won't get to every question, but nonetheless, please use the panel, the Q&A panel, and we'll get to as many as we can at the end of the session. So on the agenda today, we're going to look at what NTN NB-IoT actually is, how it compares to cellular NB-IoT, where it fits and where the applications are not so good, Viasat's roadmap and role, and real-world applications before turning over to live Q&A. I would say too, if anybody is having any audio issues or has any problems seeing the screen, if you could also drop that in the Q&A as well, it's a good steer and we can fix it before we get too far advanced. I'm going to work on the principle we're all good, and I'm going to hand over to Simon to kick us off.
Great, thank you, Liz, and hello, everyone. So I'm delighted to be joining Ground Control for this webinar and to give Viasat's perspective on non-terrestrial networks, narrowband IoT. And this was born a couple of years ago from the 5G standards under 3GPP Release 17, which brought satellites into that standards framework. The update enabled the integration of satellite communications alongside terrestrial communications within devices, and with L and S-band having been defined as the core satellite bands, Viasat sees a really interesting opportunity to leverage our global L-band spectrum assets and our existing GEO satellites for narrowband IoT use cases. Now, there are at least three large and potentially attractive NB-NTN target market segments with a wide range of use cases. Smartphones and wearables is a market with obvious scale potential. Automotive is really interesting to us with similar scale. And the third is industrial IoT, where the range of potential use cases across different industry verticals is extremely broad. And this is where we'll focus in today's webinar and talk to where we think this technology and communications waveform is best suited. Next slide, please, Liz.
I'll just interject as well. We will send everybody around a copy of the slide deck and the recorded webinar.
So in really simplistic terms, we can think of non-terrestrial networks, narrowband IoT, as just extending the benefits of cellular NB-IoT, although it's worth noting that satellite is not an exact mirror in terms of capability, and certainly applications will require some optimization for use over satellite to ensure they remain cost effective, but a bit more on that later. So satellite NB-IoT is ideally suited to applications with relatively small data volumes. It's an efficient method for sending short messages, reporting change in status of an asset, and event-driven information that's not latency sensitive. Battery life is also a key attribute. And when we're thinking about use cases that require the rollout of low-cost remote devices, it's critical for return on investment that future human interaction with those devices is kept to a minimum or simply not required at all. Sending engineers to remote locations is a costly business, and so devices need to be both durable and long-lasting. So power efficiency of both the application and the communications device is therefore a key decision for operational teams looking to use technologies for optimization. Now, a significant change that comes from the alignment with terrestrial standards is that satellite can now leverage the benefits of scale inherent within the terrestrial ecosystem. As NB-NTN becomes standardized, cellular satellite chipsets and modules become available at a cost that enables much lower cost devices to be brought to market. So this lowering of cost can open new use cases to satellite connectivity that were previously inaccessible because the economics just did not work. And lastly, the introduction of satellite into cellular standards potentially delivers global reach for terrestrial network operators. It makes the prospect of seamless and ubiquitous connectivity a reality. This can be satellite acting as an extension of cellular networks, providing infill where cellular coverage isn't available, or it can deliver service level assurance for business critical applications acting as a backup to terrestrial. Next slide, please, Liz. So we see this as being relevant for both stationary and mobile use cases, with metering, monitoring, and tracking encompassing the broad range of applications that meet the sweet spot for NB-NTN. It is ideal for stationary sensors that are located outside of cellular coverage that are sending small bursts of data occasionally, maybe just a few times a day. Think things like water level monitoring, where either a reading or a status update is required, i.e. is it too hot, is it too cold, is the level too high, too low, for example. And it's also ideal for mobile assets that may move in and out of cellular coverage. When out of coverage of a cellular tower, the device can instead access satellite coverage, the satellite effectively acting as a cell tower in the sky. Ideal for asset tracking, as well as periodically providing key information regarding the status of those assets being tracked. Next slide. Now, there are some key differences between satellite and cellular NB-IoT, and as I mentioned, satellite is not an exact mirror of cellular in terms of capability. We also show here a comparison to a proprietary satellite IoT waveform, and we've used a Viasat IoT Nano product for comparison. Message size, throughput, and latency will have an implication for whether a particular connectivity type is relevant for an application, and will determine the level of optimization to an application that's required to ensure satellite connectivity can be leveraged both from a technical and a cost effectiveness standpoint. Now, satellite needs to send significantly less data than cellular to ensure cost doesn't present a barrier to adoption, hence the importance of optimization and only sending essential data over satellite. Now, all forms of connectivity shown are bidirectional, which means each can act as an enabler for greater automation of basic tasks and alerts, driving efficiency in operations. This could be as simple as an alert to a driver to take certain action, or perhaps the remote control of a water valve to replenish water tank levels. Or it can ensure a farmer is able to understand health and status of livestock and easily locate if intervention is required. The key point here is that each connectivity type has its own sweet spot, and it's important to understand their attributes to understand if it's the right fit for the application being considered. In terms of coverage, Viasat's NB-NTN IoT offer is globally capable, if not yet globally available. We've launched in key markets, as you can see, North America, Brazil, Europe, Australia, New Zealand, and we're expanding coverage driven by market opportunity and also securing regulatory clearance. So depending on a customer's geographic requirements, this could make IoT Nano a more applicable connectivity solution, given it is globally available today. Next slide, please, Liz. So I couldn't attend a webinar without providing a quick recap of Viasat's broader satellite IoT portfolio. NB-NTN is a useful new tool, but it's not suited to all use cases. So we have a portfolio to address the broad spectrum of IoT needs, and our existing products you see here are still very, very relevant. The theme on the slide is low throughput and low size, weight, power, and cost on the left side, which gradually increases as we move to the right through the portfolio. So with lower throughput, we see a limitation in the range of applications for NB-NTN, mainly monitoring, meeting, tracking use cases, but with a much lower SWaP-C, it also means an increase in the range and volume of assets that can be supported. Where satellite was once a preserve of high-value assets, the ROI may now support lower-grade assets being connected. But you're not going to consider NB-NTN for SCADA, event-driven video, or applications with significant data backhaul requirements, where our other products such as IoT Pro, our BGAN M2M service, may be more suitable and indeed support such use cases today with tens of thousands of terminals active and supporting business-critical applications. Next slide, Liz, and I'll hand over to Ollie at this point.
Thanks, Simon. Hi, Ollie Potter from Ground Control. So any conversation we have with our customers often starts around what is the information you want to send from your remote device. really trying to determine how much information needs to be sent. And then the second thing is, how frequently do you need to have that information sent from the device back to your kind of platform? That will obviously determine the amount of data you're looking to transmit in a given period of time, so given a month for a sort of typical billing cycle. Another consideration in satellite then is the session size. So how, for a given message, what's the minimum message size that you actually have to send? And there are considerations between some of the proprietary technologies that Simon had on the other slide versus NBN IoT. For service availability, it clearly has to be in the region that you're operating in. And this is, the capability to go global, but in the major markets at the moment, power draw is very low. It's very efficient. And clearly, depending on what other sensors and things are attached to your device, will determine kind of what the overall power is. But managing the transmit power and the idle power on these is very effective. The big benefit potentially is lower hardware cost. The modules, given the scale manufacturer Simon said earlier, kind of is a big thing. Well, let me bring that to life for you. So where does the NBN IoT kind of really start to make sense? So I think in the sort of 30, maybe up to 50 kilobytes or under per month. But you have a minimum message size today using UDP/IP of 50 bytes. So if it's always in satellite coverage, I acknowledge that some devices might sit in cellular and then only be in satellite. But if you're sort of basing this on always being in satellite, you're transmitting about once an hour. Yeah, your 50 bytes will use up that 30 to 50 kilobytes in the month. So that's the sort of frequency you're talking about with a service like this. If you move forward to the next slide, Liz. Now, there's a kind of pick on three of these in particular. Kind of higher latency, yeah, it's got a slightly higher latency. You're not opening a real-time TCP/IP connection, so you are waiting sort of 10 to 60 seconds here to get a round trip fully done. And obviously, it's got a lower data rate than you have on a cellular network or even on a proprietary satellite network. But the three things I want to focus on that are really different to the cellular world you might be used to: the antenna positioning. So the antenna can't be in a building or slightly underground or hidden away somewhere. It has to have a clear view of the sky. It has to be able to see the satellite in the sky in order to be able to communicate. So you've got to then build that into the design of the hardware and kind of particularly the location of the hardware on your asset in order to see that view of the sky. Costs is then another one. So you're realistically talking about using 100 times less data, I think, than you would do on a traditional sort of cellular connection. So you've got to be very careful about how you're using it in order to make this cost effective. And then coverage, clearly it needs to work in the area or in the world you are. So at the moment, the major markets of North America, Europe, etc., but hopefully kind of more broadly as we go forward. Next slide, Liz. So I talked a minute ago about once per hour. Once per hour is assuming you're using a 50 byte minimum size message, and then you're using up your 30 to 50 kilobytes in a given month. Now, there are two underlying technologies that the network can support, or sort of protocols. So you can use UDP/IP. And if you're in the cellular world, you'll be familiar with UDP/IP, and it will be relatively easy to adopt, and your device can work both on the cellular and the satellite using UDP/IP. However, there is a messaging capability called non-IP data delivery, NIDD, and that strips out the overheads that sit in the header for UDP/IP, and it enables you to have more information sent for the kilobytes you're using. Now, the illustration on the chart there is it's using about half, but actually with a minimum session size, say down to 10 bytes, you could use a lot less. So your 1 hour, your sort of message per hour could become a message every 15 minutes if you carefully consider the use of this protocol and how your device works when it's connected to satellite. So a big consideration will be is using NIDD. It then isn't an IP connection, and you will have to consume those messages through an Amazon webhook or something from our platforms. but it's a very efficient way of using the satellite link and getting a lot more bang for your buck. Here's next slide. So really to kind of then break that down, so the overheads have gone, so that's a really clear benefit. And because you're transmitting less overhead, there's an improvement on the power consumption, which is obviously a big benefit. Clearly, UDP/IP is easier to integrate, but actually the overhead of integrating NIDD, when someone like us has done the work to sort of enable that easy integration into your environment, isn't too hard. So well worth considering. They're both secure in different ways. They are both secure methods of doing it. Clearly, there's a roaming benefit of UDP/IP. It's the same IP address. It sort of seamlessly goes across the two networks. So the messages will appear differently when you're connected to a satellite if you're using NIDD, but obviously your platform can manage that at the head end. So NIDD, super important. It will really help you optimize the use of this network and be able to send more data more cost effectively. Next slide. So really to conclude, so which network works well for NB-IoT? You've got to be sending not much data. So Simon said 50. I think it's that sort of 30 to 50 window. Under that, then this is very compelling. It's very compelling compared to the other standards that are out there for satellite communication. It's really powerful. Above that, there are brilliant technologies to use. Simon outlined some of them, and that they'll be more cost effective. They've got higher throughputs, larger message sizes. You can use TCP/IP, etc. How often you send your data? We've just talked about the frequency and the considerations, so that's very clear. How urgently is important. This is sort of using a messaging with a slightly higher round trip time. If you want a real-time control, you want to use one of the proprietary networks that can give you that open connection and real-time control. Power on this is brilliant. It is super low power. So we can see sort of 10-year battery lives with well-managed battery power in the field. And whether that's solar and battery or just a sufficiently large battery, that can work really well. And then you need to keep a careful eye on the regions. The proprietary standards are global today. This is not yet global, but I think in time it will become that. But for now, the major markets, it's really powerful. I think I'm handing back to you now, Simon, for some use cases.
Thanks, Ollie. Yeah, Liz, do you want to move to the next slide, please? Yeah, so we'll take a look at the types of applications that are suitable for NB-NTN. The common thread here is applications that are latency tolerant, low bandwidth, and power sensitive. So they support long battery life or can run on solar. And this is captured in the three broad categories we've already mentioned, being tracking, monitoring, and metering, with examples such as livestock and vehicle tracking, soil moisture monitoring, and utilities metering. Data requirements are relatively low, providing for basic status information such as asset location for machinery, vehicles, or livestock, or periodic monitoring and measurement information, typically sending messages a few times a day. Now, one of the key benefits I and Ollie mentioned is the low-cost hardware, and this is rapidly removing a barrier to adoption for many applications and assets. And what this means in practical terms is much higher penetration rates. So, for example, the whole herd of cattle is connected rather than one in every 20 head of cattle. Or all meters have dual mode capability because the incremental cost of hardware that is cellular satellite enabled is negligible or eliminated altogether. So lower hardware is critical for accessing many of these use cases, but optimization also remains really important. Limiting the frequency of message and only transmitting essential data is critical to ensure monthly costs are not prohibitive. Now, this does mean that data volumes and corresponding ARPU per device may be relatively low through necessity, but the endpoint device volumes are anticipated to be extremely high. And it's this potential for scale that makes the satellite NB-IoT opportunity very interesting for IoT solution providers and the network operators such as Viasat. Next slide, please, Liz. And of course, there are use cases, and we've mentioned some earlier, where NTN NB-IoT should not be considered, such as applications that require high data, high throughput, low latency. We can see some of those use cases here. You certainly wouldn't be pitching this for autonomous vehicle guidance or video transmission. But this also is a great example of where our existing improving proprietary solutions such as IoT Nano, MSS, BGAN M2M will be more suitable with higher data speeds, enabling larger volumes of data transfer. Next slide, please, Liz. Let's take a look at what we can expect from a product rollout perspective. And we show two routes to market here that are reflected within our roadmap for NB-NTN. The roaming service for terrestrial mobile network operators and MVNOs uses the MNO SIM and leverages their existing platforms for device and subscriber management. The roaming service is contracted and implemented via standard GSMA roaming frameworks, but is typically one way, so predominantly cellular roaming onto satellite. We don't really expect to see it in reverse, i.e. satellite roaming to cellular. Now, Viasat has service operational today via our partnership with Skylo and is developing roaming partnerships globally. The satellite-only service that you can see on the bottom half of the screen uses a Viasat SIM. This focuses on IoT solution providers such as ground control and certain OEMs specializing in remote use cases where cellular connectivity is not available, and typically some optimization will be required for cost and power. This tends to be similar to traditional satellite services. Now, in terms of what we can expect through this year, Viasat is onboarding beta test partners towards the end of this year, with service launch targeted for calendar Q1 of 2026. Partners will use API integration to Viasat to extract information for subscriber and device activation, deactivation, management, and billing. So please do look out for more information on this launch as we move through the end of this year. Next slide, please. Now, it's important that we touch on device certification for satellite. This remains important to ensure adequate performance and user experience and to allow devices onto the network. While NB-NTN leverages existing cellular standards and procedures, certain criteria are specific to the satellite system, and care does need to be taken when integrating modules and antennas. We currently have two device types, and given a relative network efficiency of each, it is important to distinguish which category is applicable, as there is an implication in respect to connectivity pricing. Less efficient Type 2 consumer devices will see higher connectivity cost versus the more efficient industrial IoT Type 1 devices, which see correspondingly lower connectivity pricing. Now, Viasat operates the device's certification process with Skylo, and there are already chipsets, modules, and devices that are certified and approved for operation over the Viasat network and are ready for use today. And if you're considering development, please note that using an already certified module certainly helps to accelerate that certification process for the device. And finally, I'd just like to give a quick pitch for the Viasat direct-to-device early adopter program, labeled DEEP. This program supports IoT solution providers and OEMs in developing devices that leverage the Viasat NB-NTN capability and network. And we have useful tools and reference documentation available to DEEP partners. And actually, to give an example of this in action, I'll now hand back to Ollie to talk through how ground control has done exactly that. Over to you, Ollie.
Thanks, Simon. We have some partners who work in the UK utility space, and they are brilliant at the sort of clean water or wastewater monitoring platforms that they then provide into the UK utilities. But their problem and their challenge was that while many of the sensors will sit within cellular coverage, 10 to 20% in the UK context sit outside of cellular coverage and needed an alternative way of connecting. In other markets, that percentage may differ, and some much higher and some maybe more similar as to the sort of satellite requirement. And while they're able to work with the sensors and build the top-end platform, they're not specialists in satellite, and they haven't been through the sort of how do you manage to make a choice between messaging or using IP connections, how do you do the power management around transmission and antennas and everything. So we've worked with them to build a device that's very simple and plug and play, that then integrates with our platform and provides their data to them directly. So it's called a RockBLOCK RTU. It will plug seamlessly into any sort of 4 to 20 milliamp sensor or some digital inputs as well. And then we can then package that data up for them, transmit that over the satellite, and then deliver that to their top-end platform. So it's very, very simple. We've created the device. We've done all of the power management and the antenna positioning that's appropriate for it. We can integrate with a broad range of sensors and then deliver that data. So if I go to the next slide, Liz. So this is the device. So we've had it for a few years, actually, and we've been using one of the proprietary technologies. And the proprietary technology is brilliant if you want more information, more frequent information, or larger messaging. But we have now, working with Viasat, we created the NB-IoT version of this product. Slightly lower cost and very compelling if you can operate in that sweet spot we talked about earlier. So we've got NTN Narrowband IoT embedded into it, and of course can connect to terrestrial cellular as well. Inbuilt edge processing, so we can do the sort of minimum, maximum, exception reporting, averaging through the device related to those sensor readings. We can manage the battery life very carefully on it, and it can easily attach to an external power source, and we have a sort of integrated battery and solar solution that will work with this as well. And then we have our connectivity management platforms that will take those messages, and they can then easily, you can integrate whether you want to send them to Azure or Amazon or an email or whatever you want to, and you can manage those subscriptions and alerts in a really simple online way. So this device is available for trials now in the NB-IoT solution. We're managing the certification for it. It can really help turbocharge your adoption of this technology. Liz. So I think that brings us to about 26 minutes past, so I think we're doing reasonably well for time. So quick takeaways before we get to the Q&A. So NB-IoT is an awesome technology. It really does extend the reach of cellular into these far-flung places. Clearly, that's within the regions that have been rolled out so far, and particularly they enable lower cost devices than kind of the proprietary technologies have done to date. It's best for smaller messages, infrequent use. We've given you the examples that through this presentation. There are other technologies that are better suited to more high bandwidth solutions. So if you're connecting a drone or you're connecting something else, there's definitely a brilliant solution out there. This wouldn't be the one for you. Latency is moderate. You're sending a message and there's a round trip time there for it to get round. If you want real-time control, you need to open up a live session and you'll be using a different technology to do that. NIDD, well worth considering. If you can then optimize the payload, then you can really bring down the cost of using this technology, and it is more expensive than cellular, so you do want to be very careful with how you use it, but it is new lower market entry price points with this technology, so it will change the game. Viasat roadmap's clearly very exciting. So the satellite only service coming next year, but you can already roam onto it today, so that network is there. So with the right use case, this is an awesome technology and you should be really considering it. Thank you.
Okay, I'm going to jump in. I'll leave this screen up for a couple of seconds and we will be sharing the deck actually, so I'm not going to leave it up at all. I'm going to let you see the gentlemen's faces in full, and we'll go through some of these questions. There are a lot, so thank you so much everybody for being engaged. I'll leave it open to both of you to see who wants to answer them. But the first question is, with NB-IoT, will the significant latency have a concern for battery management in satellite solutions?
So I'll jump in. So compared to all of the other satellite solutions that are out there, no. But yes, compared to cellular, there is a little bit further distance, a bit higher transmit power that's needed. But no, you can manage really good battery lives with this. It is actually low power, but we can work with you on that and can help you make those decisions.
And how do you see this being addressed for different industries? Aeronautics, avionics, including the airline industry, commercial industries for audio, visual, customer base, including automobiles, traffic. I think, Simon, this is more the M&O side of the coin.
Yeah, there's different. I mentioned some target market segments right at the beginning. So, industrial IoT typically covers a broad range of industry sectors. Agriculture's obvious industry that's going to be of interest. Utilities as well, where you have a lot of remote infrastructure, and also industries where you have mobile assets that are moving in and out of terrestrial coverage. I think automotive was mentioned in the question, so that's a very interesting industry for us. But some of these industries do have longer sort of adoption cycles, and we need to work with the OEMs in terms of their roadmaps to ensure this technology is incorporated into that. In terms of the capabilities, limited voice capability is something that we're looking at in this early NB phase of this. Certainly, voice messaging would be something that we're investigating. The feasibility and building that into our roadmap. So yeah, I think there's quite a number of really exciting large scale industries that this is very relevant for.
Perfect. And antenna positioning, will it work at sea?
There's no reason for it not to. The question would be coverage. So as I mentioned, we've launched in certain regions to date, and we will expand coverage as market opportunity dictates, and also regulatory access is also a key consideration. Ocean regions are clearly something we're considering and thinking through how we best provide coverage for what are large geographical areas if we move into that type of solution. So it's not currently planned, but it is something we're considering for the future.
And probably worth noting that obviously proprietary solutions do cover the ocean, so that you're not without a solution, it's just not this one.
Absolutely right. So IoT Nano, for example, would probably be the closest equivalent service within the Viasat portfolio, and that is truly global, including ocean regions.
From Nat Morris, is there any message acknowledgement for alarm type applications?
So you can use this to do two-way, and so you could build that in. Yes, but it's not acknowledged out the box. So you'd have to build in the return path to do the alarm acknowledge.
Okay. Are Viasat satellites different for NB-NTN versus the IoT Nano and BGAN services?
No, we run over the same geo satellites. So the I4 satellites, we have AlphaSat covering Europe and Middle East, and 6F1, which sits in Asia-Pac region.
And Ollie, I think this is, but if you can just confirm this, 1 ping per hour at 50 bytes per message would use up the 50 kilobytes per month, roughly. I think, is that correct? And I think that is broadly what you're...
Yes.
Sorry, there are a lot here. I'll answer up until...
But clearly, if you used a technology with us, if you used NIDD, then you've got a much higher frequency there. So, I mean, in our trackers, the sort of minimum message size we work to is about 11 kilobytes. Sorry, 11 bytes, not kilobytes. So you can get a lot of information into a small amount of data like that.
I'll just answer a couple more because there's 47 questions now, which is great. And I promise we'll come back to them individually, but we obviously already over the time allotted for this. So there's a question here from Brian, which says, how does the protocol support selection between the terrestrial cellular network and satellite? Don't know if that's a one for now or one to come back to.
Let's come back to that.
Okay, fair enough.
I mean, you would default build this so that it would always prefer cellular, and it would only then go on to the satellite connection. So you'd have a low data mode you would program into your device, and in the low data mode, it would only go into that low data mode once you've lost cellular connection. You define the parameters around when you want to do that, and then in the low data mode, you might be using NIDD or you might be using UDP/IP, and you would set the sort of frequency of transmission corresponding to the cost you're prepared to expose yourself to.
Yeah, sorry, there are a bunch of questions. So just last one, kind of random here, and I know the answer to it, but I'll ask it anyway. Is the penetration through metals good? Can we use it in iron and steel plants?
No.
And this would come down to antenna positioning, right, Ollie?
Well, if you obviously have to mount an external antenna, which you can absolutely do, but no, it won't go through metal, unfortunately.
Again, that's I do really sincerely appreciate everyone's questions, and I'm sorry, I did promise that this would be a 30-minute webinar, so I think we'll have to call it to a close, but I promise faithfully we'll come back to everybody who's answered. Well, I'll document the questions, we'll answer them, and then we'll circulate the Q&A when we circulate the recording of this presentation and the slides. And then you're very welcome to come back to us directly with your questions, and we'll be super happy to help out. But we promised 30 minutes, we're already over. I want to thank everybody for coming. I want to thank Ollie and Simon for your time and your expertise. And we'll call it a day. Thank you so much.
Thank you.
Thanks all.